All right, so good afternoon. Hope you're having a good day so far. Today is part 2 of our trig equations lesson. Today we're going to focus on, as you can see from the aim, how do we solve trig equations using identities and factoring. So by identities, I mean like Pythagorean identities, like sine squared plus cosine squared is 1, etc. And we're also going to, work in a lot of factoring in today's problems. Okay. So the do now is solve 2 cosine squared x minus 7 cosine x plus 3 equals 0 for all real numbers. So two things here. One is, this is an equation in the form of a quadratic in the sense that, there's a square term like cosine x squared. And, it looks like a quadratic equation, right? The second thing is you're solving for all real numbers. So just like yesterday, we're going to have to, tack on like 2k pi, k pi, etc., depending on the situation. Okay. So there's actually a lot of questions I want to go through today. So actually, let me just jump into the solution for the do now. All right, so you're going to see that we're going to use the AC method. And if you remember from Algebra 2 last year, the AC method is a method of factoring when you have a non-1, meaning the quadratic coefficient is not equal to 1, right? So the coefficient in front of the square term, in this case cosine squared x, is not 1. So we're going to take the quadratic coefficient 2 in this case, multiplied by the constant term, which is c, right? So that'll be 2 times 3. And at this point, you have to think of two numbers that multiply to 6, right? 2 times 3, and add to -7, right? And they could be negative. And if you think about it, it's going to be equal to -6 and -1, right? Because -6 times -1 is 6, right? So that pans out. But, that tells you how to split up the middle term, which is -7 cosine x. So you can split it up into -6 cosine x and -1 cosine x. Okay, so we just split the middle term, -7 cosine x, into -6 cosine x, negative cosine x. Okay, from there, you can factor by grouping. So I'm going to factor these two terms here. So factor out 2 cosine x. From these two, you get 2 cosine x times cosine x minus 3. And then the latter two terms, this pair, you factor out -1. So it'd be -1 times cosine x minus 3. And that all equals 0. At this point, you're going to factor out the common term, which is cosine x minus 3, right? Because both these terms have that term, right? So it'll be 2 cosine x minus 1 times cosine x minus 3 equals 0, right? And you can always check, right? Like if you multiply this 2 cosine x term times this entire factor, cosine x minus 3, then you get the term on the left. If you multiply -1 times this term, then you get the term on the right. Okay. All right, from there, you can use the zero product property, right? So if two numbers multiply to 0, then you know that one or both of the terms has to equal 0. So from the first equation, we get this equals 0 or cosine x equals 1/2. And from there, we know that the angles are going to be 60 degrees and 300 degrees, or 60 degrees and -60, if you want to say that. From the second term, the second equation, I mean, you get cosine x equals 3. But here there's no solution because cosine is never greater than 1, right? The max value is 1. So here there's no solution. Okay, so that gives us our final answer. We'll have pi over 3, which is 60 degrees, plus 2k pi, right? Because we're solving for all real numbers. And then the other answer is going to be 5 pi over 3 plus 2k pi. And where k is an element of the integers. All right, so I'll give you a sec to copy this down, and then we'll move on to the next example. All right. Does anyone still need to copy the solution? No? Okay. If not, then I'll move on to the next example. So today's lesson is actually, there's going to be 4 examples. We might not get through it all today. So actually, I'm planning on, splitting this lesson up into 2 lessons. So we'll go through as many problems as we can today, and then we'll go through the rest tomorrow. And for that reason, I made the homework, instead of being due tomorrow, I made it due on Monday, okay, at 11:59. Okay, just FYI. All right, here's the first example. So here we have cosine x tan x plus 1/2 tan x equals 0. And note that we are solving over all real numbers, so like on R, that means over all real numbers. Okay, so cosine x, I just changed the tan x to sine x cosine x. Oscar says I'm cutting out. Oh, okay. Well, you can always, yeah. So if it's cutting out now, feel free, you just catch up on the audio recording. Yeah. All right, let me just proceed though. So we have tan x equals sine x over cosine x, right? Change that. And then from there, right here, the cosine x term divides out, right? So we get sine x here, and then if you multiply this, you get sine x over 2 cosine x equals 0. From there, you can factor out sine x, so you get sine x times 1 plus 1 over 2 cosine x equals 0. And then there you use the zero product property, right? So sine x equals 0, or this entire thing, 1 plus 1 over 2 cosine x equals 0. From the first equation, we have x equals k pi. Okay, so think about that for a sec. So just ask yourself, where is sine equal to 0? The answers would be 0, 0 degrees, right? Pi radians or negative pi radians, or 2 pi, negative 2 pi, etc. So every multiple of pi will have a sine value of 0. Okay, so I just write that as k pi. From the second equation, we have to do a little algebra. So we have 1 over 2 cosine x equals -1 by subtracting 1 from both sides. Then you cross multiply, you get -2 cosine x equals 1. And then from there, I'll divide both sides by -2. Okay, so we get cosine x equals -1/2, meaning, cosine is negative in quadrants 2 and 3, right? So this is our answer right here, right? It'll be 120 degrees, which is in quadrant 2, and then 240, which is in quadrant 3. Okay, so in summary, our answers are k pi, which comes from this first equation, sine x is 0. Then we have 2 pi over 3 plus 2k pi, then 4 pi over 3 plus 2k pi, where k is an element of z.
Why is it plus 2k pi again?
So it's plus 2k pi. Well, actually, does anyone want to answer that? Just to review. So why do we have 2k pi here? We talked about this yesterday. Does anyone remember?
It's the period for cosine and sine. So you just add the period.
Yeah, it's the period for cosine and sine. Yeah, good. So, and you can even like just reason it out. So if you have like 120 degrees here, then if you add 2 pi to this, you're going to end up at the same location, right? And same thing if you subtract 2 pi, that's, clockwise rotation. So every multiple of 2 pi, if you add it, then you're going to get a valid answer. That'll work for this equation. But it has to do with the period of cosine, which is 2 pi. All right, anyone else still need this, or any questions about this first question? All right, if not, then I'll move on to question 2. question 2, we had 3 cosine A equals 2 sine squared A on 0 to 2 pi. So here we're solving, in a finite range, so like 0 to 360 degrees. So note that 360 degrees is not included, so we don't have to include 2 pi if it comes up. Anyways, what that means for us is we don't have to add like 2k pi or k pi or anything like that. Okay, so first thing I want to do is use the Pythagorean identity, right? So sine squared A plus cosine squared A is 1. And I'm going to use that to substitute on the right-hand side, right? So from here, you can get that sine squared A equals 1 minus cosine squared A. So that's what I do here. So again, I'm replacing sine squared A with 1 minus cosine squared A. And that comes from the Pythagorean identity, right? From there, you just distribute the 2. So you get 2 minus 2 cosine squared A. And then I want to be able to factor this, so I'm going to move everything to one side. And I like to have, a positive quadratic coefficient. So I'm going to add 2 cosine squared A to both sides and then subtract 2 from both sides. So we get 2 cosine squared A plus 3 cosine A minus 2 equals 0. From there, I'm going to factor. So you get, your factors are going to be 2 cosine A and cosine A, right? Because it has to be 2 cosine A squared, or squared A, I mean. And then your other two numbers in the factored pairs are going to be, they have to multiply to -2, right? So it's going to be 1 and 2. And after a little guess and check, you can discern that it's going to be negative here and positive here, right? Because 2 cosine A times cosine A is 2 cosine squared A. Then 2 cosine A times 2 is 4 cosine A. And then -1 times cosine A is -1 cosine A. If you add 4 cosine A minus cosine A, then you get 3 cosine A, which is the middle term. Lastly, you do -1 times 2, which is -2. Okay. All right, so there you have your two factors. So you can solve for the angle. So from the first equation, we have cosine A is 1/2. So therefore, it'll be pi over 3 or 5 pi over 3, just like I think that was the do now, was it? Yeah, the do now. So yeah, 60 degrees and 300 degrees, right? As you see from the diagram here. Quadrants 1 and 4. From the second equation, we will get no solution, right? Because cosine A can't equal -2, right? The lowest value is -1 for cosine. Okay. All right. So our final answer is therefore just pi over 3 and 5 pi over 3. All right. I'll give you a sec to copy that down and then go on to question 3.
Wait, Mr. Ling, I have a question. For like when you write like the solution, like the answer to find all real solutions, can the k be a negative number? I know it could be an integer and it could be 0 technically, but like can it be a negative number?
Yeah. So well, negative numbers, like integers can be negative also, right? So like -2, -1 is also included in the set of integers. Yeah. So the answer is yes. You can have like -1, -2, -3 for k.
No, I know, but like I just didn't know if it would like land on the same and like it would be the same angle, counter clockwise instead of like going like clockwise, like in the negative direction. It goes like the other way. So
Yeah, that's still okay, right? So like for example, like for the first question, right, we had 4 pi over 3, right? So 4 pi over 3 is quadrant 3. If you do like -2 pi, right, then you rotate clockwise, so that'll be this way, and you end up at the same location. Right? So like -360 is clockwise, and you end up at the same location as if you did +360, which is counterclockwise. Okay. Anyone still need question 2? I'll move on to question 3. All right, question 3, we had sine 2x minus cosine x equals 0 on all real numbers. So we are going to have to, add 2k pi to our solutions. So first thing I'm going to do is actually apply the double angle formula. So if you remember from like that October lesson, right, like we had sine 2x and we derived 2 sine x cosine x from the angle addition formula. But anyhow, it's like sine 2x is 2 sine x cosine x. From there, I'm going to factor out cosine x from both terms. So you get cosine x times 2 sine x minus 1 equals 0. And then we're actually done factoring. So from the first equation, we get cosine x is 0. And you can discern that it's going to be pi over 2, which is 90 degrees, as shown here, right? Or it's going to be 3 pi over 2, right, which is 270 degrees. From the second equation, we get sine x is 1/2. Okay, so sine x is 1/2. The two angles that are possible there are going to be, between 0 and 360, are going to be 30 degrees as well as 150 degrees. So that's pi over 6 or 5 pi over 6 in radians. And then, so I write my answer. So I actually compact pi over 2 and 3 pi over 2. So I combine them into pi over 2 plus k pi, right? And the reason for that, the reason I can do that is, if you notice here, right, if you pi over 2 and you add pi, if you add 180 degrees to pi over 2, 90 degrees, then you get 270, right? So you end up here. And then if you add another pi, you get back to the same location as 90 degrees, right? So like these two answers can be summarized into this, right? Now, granted, you can, if you want, you could write this out, right? So you could do, you can split it up into two separate terms, right? But I summarize it into this as pi over 2 plus k pi. Okay, so that's what we get from this first equation. From the second equation, we get pi over 6 plus 2k pi and 5 pi over 6 plus 2k pi. Okay, any questions about that? I know this was this was new, like just combining two different sets,
Can you explain how you combine the two answers again?
Yeah. So normally we would have pi over 2 plus 2k pi and 3 pi over 2 plus 2k pi. So essentially that's just like pi over 2 plus 2k pi is 90 degrees plus another 360, that's 450, right? And then 3 pi over 2 plus 2k pi is 270 plus another 360, right? So in other words, we're just, our solutions are going to be located at these points, right? So here and here, right? On the positive and the negative y-axis. But you can combine that, you can like shorten that solution into a more elegant solution by writing pi over 2 plus k pi, right? So 90 degrees, which is pi over 2. If you add 180, then you end up here. And then if you add another 180, you end up here. And if you keep doing that, right, you just end up at the, all the possible solutions, which can be described using pi over 2 plus k pi.
Thank you.
Yeah. But yeah, if you don't feel comfortable doing that, you could always just rewrite, like write this entire solution out. That's totally fine. Yes, Dorothea?
So for problems like that include tangent, is it like, do you prefer us to like break it down into sine over cosine?
You mean like for like solving, like the algebraic steps?
Yeah.
It all depends. Like, so I usually do that, but actually, as you'll see on the homework that corresponds to this lesson, there's like a question you could do, like you could either just do tangent, leave it as tangent, or break it up into sine and cosine. In my solution set, I did sine and cosine, but you can do tangent also. That's totally fine. And actually, I realized after I did it that it would actually be shorter, like a few shorter steps if I just left it as tangent. But yeah, it's up to you. Yeah. Okay, so actually, that's all I wanted to say for today. I'll start with question 4 in tomorrow's lesson, and then we also have like the classwork worksheet. So that's what we'll do tomorrow. For closing announcements, there is SGI today at 2:47. You can drop by if you have questions. And secondly, reminder that our next quiz is next Friday on the 11th. Okay, I'll send out a topics list over the weekend per usual. But yeah, so, oh, and also I changed the homework due date for this lesson to Monday night, right? Because yeah, I want to go over the rest of the questions here. So yeah, just FYI. All right, but yeah, if you have no further questions, we can end a minute early, and I'll see you tomorrow. All right, take care.
Thank
Have a
you.
nice day.
Thank you.
Thank you.
All right, you're welcome. Take care.